In today's lesson, we are going to have a look at true bearings. So to start with, let's have a look at some of the basic things we need to know about true bearings. True bearings are always measured from the north. So the only direction we take into consideration while measuring true bearings is the northern direction. The second and the most important thing, a true bearing is always measured in a clockwise direction. The values that a true bearing can take will be between 0 to 360. So here are some examples: 125 degrees T, 270 degrees T, where the symbol T basically refers to it being a true bearing. For true bearings less than 100 degrees, for example a 45 degrees T or a 78 degrees T, we need to make sure we enter the first digit as a 0. Similarly, if we have a true bearing, say let's say it's 7 degrees, we have to represent it as 007, and that's the only thing that's going to make James Bond very proud. Now let's have a look at a diagrammatic representation of a true bearing. So obviously we take into account only the northern direction, so we're going to mark the north direction. And remember, we're only measuring it in the clockwise direction. So which means the starting value at north is going to be 0 degrees. That's going to be 90 degrees, 180 degrees, 270, and a complete revolution gets us to 360 degrees. And hence the value of a true bearing can only be between 0 and 360 degrees. Now moving on, let's have a look at an example where we apply some true bearings. So in this example, a boat travels at a bearing of 160 degrees T for 6 kilometers. And in part A of this question, they've asked us to draw a diagram to illustrate this situation. Now again, let's just mark our northern direction. Now 160 degrees, so I've got 90 degrees plus another 70 is going to get me to 160 degrees. So the direction the boat's going to travel is roughly in that particular direction, where the distance that the boat traveling is 6 kilometers. So let's say the boat travels from point A to B, for instance. Now, in terms of marking the angle, I'm not going to mark the full 160 degrees because this is 90 degrees. So this is my 90 degrees. So what is left of 160? The value that is left out of 160 is a 70 degrees. The reason why we do that would be more clearer as we go to the next section of the question. So in part B of the question, they want us to find out how far south is the boat from the starting position. So let's have a look here. I am going to complete a right angle triangle in this scenario. So I'm just going to complete a right angle triangle. And if I complete a right angle triangle, now this is my point A is my starting position and point B is my finishing position. And I can see that's how far south the boat has traveled. So let's just call this distance as x. So in this case, x is our distance traveled south. And if you notice the next part of the question, how far east is the boat from the starting position? Now, the four directions that we have is north, south, east, and west. And looking at the diagram, that is the distance that the boat has traveled east from the starting point. So let's just call that as y. So if I put this triangle by itself, I can see that I have a right angle triangle there. This distance is 6 kilometers, and that's my x, and that's my y. Now it's a right angle triangle. I also know that that angle is 70 degrees. So I have an angle inside the triangle, which means we are going to try to use SOHCAHTOA to work out the missing sides. So let's label the sides. So obviously that's my right angle. which makes 6 kilometers the hypotenuse. 70 degrees is the given angle, which makes x as the opposite side and y as my adjacent side. So, in part A of the question, we're trying to find how far south is the board. So which means we're trying to find the value for x. So the ratio for x is my opposite side and 6 kilometers my hypotenuse. So the only ratio which has O and H is our sine ratio. So let's use a sine ratio. So which means I'm going to have sine of 70 degrees equals, I can see my opposite side is x and hypotenuse is 6. So I'm going to go x over 6 and I'm going to solve that on my CAS calculators. So we're going to go menu, algebra, solve. Now let's make sure that our calculator is in degrees for this calculation. So sine 70 degrees x over 6 comma x, control enter. That gives us the value for x is 5.64. So the value for x is 5.64. Now units is kilometers, and that's the distance we have traveled south of the starting position. So moving on to my second part, which is how far east is the board. So if you have a look at this diagram again, the east distance in this triangle is y, so which is our adjacent side, and 6 kilometers is our hypotenuse. For this particular situation, the only ratio which has A and H is our cosine ratio. So we are going to use the cosine ratio for this example. So cos 70 equals adjacent side is y, hypotenuse is 6. And if we solve that on our calculators, so menu, algebra, solve. In our trig function, we are selecting our cosine function. Cos 70 equals y over 6 comma y, control enter, gives us the value for y as 2.0 kilometers east. Now to get to the final section of this question, they want us to find the bearing the boat needs to travel to return to its starting position. So let's just quickly revisit this diagram. So we travel at a direction of 160 degrees T for 6 kilometers. So 160 degrees, again that's my 90, that is 70 degrees, and we reach another point B. Now I'm just going to draw a compass here. Now we need to figure out what direction we need to travel to go back to the starting point. Now if we think about true bearings, we measure it from the north and we measure it in the clockwise direction, so which means the direction or the angle we need to travel is that arrow there. So let's have a look at this here. So this bit here is a 90 degrees. That's my 180 plus another 80, which is 270. Now if we consider this diagram here, that's 70 degrees, and this angle here is our alternate angle, so which means that is also going to be a 70-degree angle. So which means the bearing of A from B in this case is going to be a 270 plus 70, which is going to be 340 degrees T. So let me repeat this again. Now these two angles are alternate angles, so which means they are going to be equal to each other. That's my 90, plus 90 is 180, plus another 90 is 270, plus 70 gives us 340 degrees T. And that's the direction the boat needs to travel to return to its starting position.